are these two lines parallel? And the answer is yes, because they gave us these little arrows there that tells us that these two lines are parallel. Therefore, angle P and angle R, see the first angles that are mentioned here, angles P and angle R, are congruent to each other. And same deal for angle S and angle Q, because they're alternate interior angles created by a transversal that cuts across two parallel lines. Therefore, those are congruent to each other. And therefore, since we've said all the corresponding parts are congruent of these two triangles, therefore the two triangles are congruent. Okay, so you do not have to do anything for that one. Don't worry about that. The rest of this will go by very quickly. We have a theorem here, third angles theorem, that tells us that if I have one pair of corresponding angles in a triangle and a second pair of corresponding angles that are congruent, then I know for sure that the third pair of corresponding angles will also be congruent, because we know that the sum of the interior angles of all triangles is 180 degrees. So if we take away something and another something from 180, then what's remaining is the same amount from those two angles. So therefore the third angles, as long as we know that two of the angles are congruent in a pair of triangles, then we know for sure that the third pair are also going to be congruent. And then remember back in 2.5 we learned these properties of equality. Reflexive, little a looks at himself in the mirror. What does he see reflected? He sees himself. A is equal to A. Symmetric, if A equals B, then we can say that B equals A. And then transitive, if A equals B and B equals C, then we can transit through B and say that A equals C. Those three properties also apply to triangles. That if triangle 1 is congruent, or triangle 1 is congruent to triangle 1, that's reflexive. Symmetric would be, what would symmetric be? Oh yeah, that if triangle 1 is congruent to triangle 2, then we can say that triangle 2 is congruent to triangle 1. And then transitive would be the same idea, that if triangle A is congruent to triangle B and triangle B is congruent to triangle C, then triangle A is congruent to triangle C. I'm using different designations here that are a little bit easier to understand. But same concept with triangles that we did here with letters or with numbers or with angles. We did all those before. Same concept. Okay, so now it's your turn to do number 4 and also number 5. So in this diagram down here, what is the measure of angle DCN? DCN. So what is the measure of this angle? And do you know that these two triangles are congruent? And they are. How do we know that? I don't think we have enough information here. But let me tell you that they are, based on what you know. You do not have enough information yet. But let me tell you that these two triangles are congruent. So you figure out a statement, a congruent statement. Would you do that? Let me start you off. Triangle, let me start with a CDN, okay, is congruent to, and you tell me what the sequence of this other triangle needs to be for that to be an accurate congruent statement, okay? And then tell me what the measure of this angle is, and also by the definition of congruence, what additional information is needed. There it is. So what other information would you need to know to be able to make this statement here? In other words, what other parts, corresponding parts, would you need to know are congruent in order to be able to say that they are congruent? Okay, hopefully that's helpful to you, and I look forward to seeing you in class.